now we have Dave telling us building a modern packet radio network with open source software, which I know nothing about, so I'll happily pass on. Welcome, Dave.
Perfect. Good afternoon. Yes, I'm going to talk about building a packet radio network in the current year using old technology. So for a bit of background, I'm Hibby, known as MM0RFN in the amateur radio world. I am unfortunately, first and foremost, a Debian developer, so that means that most of my solutions come from an insane Linux point of view. I'm a packet radio enthusiast. I like sending slow data all around the world. And I got a start in amateur radio in 2007, having heard about packet radio from a podcast called Hack 5 in the year 2006. I started my time in Debian and getting serious about open software in 2015, just fixing bugs, starting doing one or two things and got slowly more sucked in. But I found myself drawn towards BSDs. I'm quite excited by them in general. And because of my excitement for amateur radio, I am a career radio engineer. I spend my time in a day job doing communication safety systems for the energy industry. So a quick summary of what we're going to go over. I'm going to do a brief introduction to amateur radio because not everyone is familiar with it, and I will arm you with some very helpful technical knowledge. I'll give you an introduction into what is now the UK and Ireland packet radio network, and then tell you how to get involved as well and what we're looking at next. And throughout, I'm going to have helpful graphics like this. They come from the Northeast Digital Association's 1994 annual, which is contemporary with the bulk of the technology that we're using. It's really not come on very far. So amateur radio is an old hacker hobby. It's been around for 100, 120 years. It really is a license to experiment on the radio frequency spectrum. Amateurs have access to a huge chunk of radio, all the way from long wave, 135 kilohertz is the bottom of the UK allocation, up to impossibly high frequencies, 250 gigahertz is the top end. The most attainable bands for everyone is 1.8 meg to 2.4 gig, with 10 gigahertz becoming more achievable as commercial hardware makes it cheap. The most common bands that you'll see are 144 meg and 430 meg. These are the common walkie-talkie bands, and they're just quite a nice size. You have to have a license to get on the air. Most jurisdictions have reasonable licensing these days. In the UK, we have a three-tier system. Foundation is a barrier to entry that isn't very high to cross. In Ireland, it's a bit more difficult. There's a Class A and a Class B license. The only real difference is that you can do Morse code. Most other places have got rid of Morse code at this point in time. And everything that happens in amateur radio happens in the clear. There is no encryption. So we have a predisposition in the hobby towards experimentation and sharing. And it also stops corporate heavyweights coming in and stealing our band space. It's a hobby with a diverse range of sub-activities, and each one further subdivides. The same as software. You get a bit interested in networking, and then you get a bit interested in TCP, and then you get a bit interested in something else. You just keep going down and down and down. My preferred sub-activity that I do is create an ultra-lightweight portable station, climb to the top of a mountain and speak to strangers in different continents from the top of that mountain. There's people who do amateur television, so it's not just talking to each other. So they're experimenting at the moment with DVB and DVB-S. There's experiments in DVB-T, which is multi-carrier, and that's quite exciting. There's a bunch of people who launch satellites, amateur satellites, and they've been going on since the 1960s. In 1961, Oscar 1 was launched. That's 4 years after Sputnik. So radio amateurs have been trying to do impossible things on shoestring budgets for a long time. And the other one that I'm excited about, packet, is what I'll talk about today. Theoretically, it's a technical hobby. You have to know about radios, but it doesn't have to be. And there are people who just sit in their front room and speak to each other on a radio. And during COVID, that was a lifesaver for some folk. It's relatively easy to get started, as I say, with licensing. And overall, it is a bit ridiculous. This is me trying to talk to someone 10 miles away. I'd spent the afternoon talking to people much, much further away, but he couldn't be bothered getting out of his front room. So I had to wander around the top of a hill with 6 meters of carbon fiber above my head. Packet radio. Well, packet radio is a niche within amateur radio. And it is just Wi-Fi from long before the IEEE came up with the 802.11 working group. It's real slow networking over commercial hardware that we can buy off the shelf. We're all given call signs when we get our amateur radio licenses, and they form your addressing. It often gets confusing when you have a MAC address that is a call sign and an address for a layer above that that is a call sign, and a port might be a different call sign. So you can have very conflicting and terrible addressing schemes. It's all derived from X25, so that should give you an idea of how old it is. And there really are a limited number of applications that are common. Messaging and location tracking. The top picture is me driving home a couple of weeks ago. You can see where the big straight lines are, where the coverage gaps are. We use BBSs. BBSs are still cool. Don't stop doing BBSs. And file transfer through BBSs as well. And we're moving into general data transport as well. But that's still quite a niche part of packet radio. It is contemporary with early IP. Some people have called it a more elegant weapon from a more civilized age. And a lot of the state-of-the-art started out as homemade EPROMs that were passed around by friendly hams for Z80-based hardware. And this advert from page 76 of the Northeast Digital Association's annual is someone who wants to share his code either as a diskette or a ROM. And you can send him a message on his BBS 30 years ago, or you can turn up at his house and ask for it. The first documented experiments in packet radio were in Canada in 1978. And it's really grown arms and legs since then. And then the internet came along and it kind of fell away. Everyone got bored of slow networking. But it's still good fun. You can get BBS bulletins. You will absolutely not regret getting another 5 to 10 messages a day that mean absolutely nothing. I don't get many personal messages, but I do get this list every day. Arch Linux updates, Linux Today. If we look at this one, this is the Linux Today bulletin. You can see at the top all of the hops it's taken to get to me. It starts off at the bottom, LU9DCE, who's in Argentina, and it works its way through the US, over to the Netherlands, back to the US for no reason whatsoever, and then ends up in Scotland. And this is just an excerpt of the Linux Today headlines. It is just the headlines and the leader text. There is no link to go to the website. You cannot learn more. You just get, there is a post on Linux Today, should you like to read more? It's great, I love this crap. It's helpful to know, as we go forward, that when I talk about packet radio in the UK network, we're really dealing with 3 categories of link. We have our low-speed links, which are 300 bauds, that is characters per second. Sometimes we can do more than 1 character per second, so it might be 300, 600, 1200 bits per second, but it's always about 300 baud. We have a medium speed link, which starts at 1200 baud, and then a high speed link that is rocket fast at 9600 or faster. The low speed links are typically on the HF bands, that's 1 to 30 megahertz. It's really narrow bandwidth, and it's a really big size bit of equipment. This is my smallest HF antenna, and it really does just keep going and keep going and keep going. It's about 5 meters long, but I've been known to climb hills with antennas that are 30 meters, if not longer. In our mid-speed bands, that's VHF, 50 to 145 megahertz, so around about where you'd find marine traffic and air traffic. It's mid-bandwidth, and it's mid-sized equipment. The antennas are much more convenient. This one is only half a meter long, and it's lightweight and cheap. And then in the UHF bands, where we get to high speed, because we have lots of bandwidth to play with, the antennas get real small, and it becomes easier to make directed antennas. You move into dishes and microwaves and other fun technology. Of our links, the low-speed ones are intercontinental, and what we do is take advantage of physics in the Earth's ionosphere. So the HF bands are largely controlled by the sun. We pray to the gods of the sun that everything goes well. The sun has what's called the solar cycle. It's an 11-year cycle of activity. At the moment, we're approaching the high point, the maximum of the solar cycle, which is why we're seeing lots of aurora and lots of atmospheric effects. And what we do is we take our signal and shout it out into the ether and hope that it reflects off the very top of the ionosphere and comes down somewhere else 1,000 miles away. If the sun is particularly angry and it has released a lot of X-rays and particles, then this thing at the bottom, the D region, will get quite absorby, and it will stop the signal going through it, and you can't hear anyone. And it impacts satellite communication and other things, but it really cuts off our slow-speed backbone links that we're proud of. The medium-speed links are local area. They kind of reflect around a city quite nicely. You can do it from a car. You can do it from a hill. You get a good 50, 60 miles, 100 kilometers of range. And in the high-speed links, they're really just line of sight, point to point. So you're creating a backbone effectively. But as a packet radio fan, you control the full stack. You have every element of the hardware and every element of the software is up to you what you choose to do. In 1994, it looked a bit like this. You had a big white stick at the top of your house, and that was your local link. And then you had a radio below that. You had a thing below that called a TNC, which is roughly equivalent to a network operating system device, and it also contains your modem. And then you had a dumb computer at the bottom. And computers are still dumb, but they're now a lot more powerful. The radio, you just change out for different bands. The antenna, you change out for different bands. So this is one of my high-frequency radios. It's quite small and compact. It only does 20 watts out, so it doesn't go that far. But I do take it up hills, so it's not too bad. It's not very OSI. It's from a time before the OSI 7-layer model was invented. So yeah, things clash and the schemes don't work, and layer 2 has a full connection model in it that asks for retransmissions instead of layer 4, and it's not the best, but it works. And yeah, you can change every bit of the stack, and as time has gone on, I say as time has gone on, from 1978 to 1994, things became software. So the TNC is now software. That's just a node stack that's on a computer. There's a few different implementations of that. The modem is now just software because computers can make noise. And we're not making a lot of sound, and we're not making it very quickly, so we'll just make things come out the sound card. The radio, well, software-defined radio is now a thing. And you essentially get a rack mount unit that can pretend to be a radio on the network, and it makes it much easier to go on strange bands. Cables can get quite expensive. The cable that connects your transceiver to your antenna is a great way to spend money in the classic audiophile style. Sadly, while your antenna can be many things, it cannot be made into software. We can control them with software, but we cannot make the antenna software yet. And computers can now be tiny. We've got Raspberry Pi 2, 0Ws, and all kinds of stuff. They get smaller and smaller and smaller. So we've taken this idea and told a whole load of people about it and started the UK and Ireland Packet Radio Network. And this is a map of what it looks like at some point throughout the day. All the small pins are different stations of different classes, yellow and green. And the one in the top left there has a couple of long-distance, slow shortwave links that are coming down here to England to send bulletins and emails and nonsense back and forth. It is inherently a social network because to peer with someone else locally, you have to speak to them and tell them that you want to connect to their radio. It doesn't just happen automatically. We haven't really invented routing protocols yet. But yeah, each bubble of these is a local area of people who've spoken to each other and started a mid-speed or high-speed network. And down here in England, they've spoken a lot and they've done quite well. And up in the northeast of Scotland where I am, there's 4 guys, and sometimes we all fall out. There's a mix of experienced people who've been doing this for 30 years, if not longer, and there's new people who've only had their license for 2-3 weeks because they heard about it and thought it was cool. And there's a real mix of technical ability as well. Some of our operators and people struggle with the concept of mailing lists, and mailing lists can be quite difficult, but sending a new email with a new subject every time you want to reply to someone's question is a bit frustrating. But we do follow the tradition of what's gone before. On our layer 1, we have FSK, we have something that makes noises. On our layer 2, we use a protocol called AX25, and increasingly these days, we use something called IL2P, inspiringly named the Improved Layer 2 Protocol. It has such great features as checksums and forward error correction. We're really pushing the boat out. And on layer 3, we have NetROM. And as its name suggests, it was distributed as a ROM for networking quite some time ago. NetROM is a bit like Marco Polo. Your station announces its presence and says, I'm here. And everyone else says, that's great. I can hear all of these stations. And you build a routing table, and you can begin to move around the network. That only works locally. AX25 has a maximum packet length of 256 bytes. NetROM is an overhead of 20 bytes in that window, so that reduces our payload to 236 bytes. And on a link where you're sending 300 bits a second, that is a measurable amount of time. So we don't do NetROM on the HF links. We just know that we're going there, and we've set up our peering agreements in advance. This is a network in a different day. You can see the sun's a bit happier today because now my station in Aberdeen can also talk to England. Sometimes I'm grumpy with the English, sometimes the station's grumpy with the English as well. So we've made our network around a thing called a Nino TNC, which is a modem that's been made by a guy in the US, and it is a modern solder-at-home kit that is still under active development. And someone down in England, a guy called Tom, M0LTE, organized a group buy of boards through a Discord server that a lot of people were in back in November 2022. And we started supplying these things. The map didn't look like this in day one. We started off with 10 people wanting one, then 20, and all of a sudden we had 100 orders, and now we've shipped a couple of hundred of these things around the UK, and people have got really excited. Having the gear is great. Like, what's next? Now that I've got this and I can make my radio sing, does anyone else hear it? And the challenge of packet radio, once you've got all the gear, is that it's an overwhelming collection of information from 30 years ago, targeting mostly DOS, fragmented across some truly terrible-looking websites. And the state of the art is not in a good state. Like, we're using 30-year-old software, or software that's been in development by an amateur for 30 years. And we have bugs all over the place, and this was never meant to compile with GCC 14 or GC wherever we are now, and it's not meant to build to these standards. And I spend so much time patching terrible software. And it's a weird mix of closed source software and open source software, and there's a load of gatekeepers in there as well, just to make everything fun. And as I suggested at the start, there's just weird dead messages bouncing around all the BBSs, taking up airspace. Like, the state of the art isn't great. But to at least get involved, you have to find some local friends. If my radio can shout, someone has to shout back at some point, and if you're just shouting into the void, like as cathartic as it is, it's not very helpful. So we discovered that you could link systems together using the internet protocol. We could encapsulate AX25 over IP and then shoot it off to someone else's station over a VPN. So we built a virtual packet radio network where we could talk to each other using all the right technology, but over WireGuard. And that was good, and we've slowly replaced those long-distance links with the shortwave links as we've got better and better. And then we bounced against the law. In the UK, radio law has typically been quite suffocating for the experimenter. For me, as a license holder, to set up an unattended station, well, I was fine to do it because I have a full radio license, which used to be called the advanced radio license. But if someone who holds an intermediate, the second level of license, or a foundation wants to do it, they're not allowed to because they haven't sat the right exam. And while the exam says that you know the base amount about radio, it doesn't necessarily say you know how to remotely turn a computer off and on, and the licensing body were very concerned about people with computers. So laws exist to be bent, and we gave some people some good advice on just how to do things and what unattended operation could be interpreted loosely as, and how to experiment with things. And then we got the opportunity last year to change the laws. We started speaking to the body that coordinated all of the packet stations in the UK and highlighted some things that didn't make sense, and they reissued the allocation of frequencies. And then the radio regulator in the UK, Ofcom, came knocking and said they would like to change radio law because they really can't be bothered dealing with us as radio amateurs. So they made everything a lot more permissive. And now a foundation license holder in the UK can just pop up an unattended station. You can't use too much power, but can do it. And an intermediate license holder can put up a full power unattended station. And the network blossomed. As soon as we had freedom from regulation, it got much easier. And other people wanted to get involved too. So the network extends out to Gothenburg and Hamburg and the Netherlands now as well. And usually at night, my station will connect and we'll get messages from the continent. And of course, because I'm a Linux person, I came up with a stupid Linux problem, or a stupid Linux solution to a problem that didn't really exist. So the Raspberry Pi is popular, and we want lots of people to do packet radio, so surely we can bring the Raspberry Pi and the packet radio together. I also happen to maintain all of the packet radio infrastructure in Debian, and thus the Raspberry Pi. It trickles down. And Raspberry Pi OS trails Debian by about 6 months, and Debian, when we release stable, well, we've been in a freeze for about 6 months, So by the time that a Raspberry Pi gets something, it could be 12 months out of date at, in the best of situations. So there must be a way to get people newer software on Linux than just pulling it off the internet. So I came up with some ideas, and we'll get to where I ended up with that thought later. But what I did learn is that free software is just really hard for people. They're really scared to play with computers, and telling someone that they can nano edit this config file, vim edit this config file, is just not a valid option for a lot of the new people that we had joining our group. And we had to work out how to teach them how to do that. And it's compounded by the fact that the software is old and fiddly, and it's often just distributed as binaries by an author with no code behind it and no way of understanding how to engage with open communities. And then there's a documentation. Well, I said the websites are bad. Well, we tried our own documentation, and wikis, well, wikis are a great source of information, but people forget they exist and nobody ever reads a wiki. And we exist in Discord as a community, and Discord is horrible. It eats everything that you say, and it doesn't return it in a helpful manner when you search, and it doesn't put it on the open internet. And all of the conversations you have and discoveries you come up with and ideas and thoughts really should just be considered lost by the time they go into Discord. And the wheel keeps getting reinvented, and we keep coming up with the same ideas. And the people who are writing the software just want to write the software. They don't want to write documentation for the software, which is understandable. So I started to write a coherent guide, and people got excited about the packet radio guide, and then Linux Brain came on. And I invented Hibby's packet radio repo, which is an idea that brought a lot of work. So I thought I'd abuse my Debian hobby of building software for other people to build software for other people in a radio context. And my first response was, yeah, just copy repo.list to app sources list D and my GPG key to trusted gpg.d, which, to anyone who is not into command line, is the ramblings of an absolutely unhinged madman, and we had to rethink that quickly. So now there is a package that you install, and it sets up your computer, and I get permission to install whatever I want on your machine. And what I'm trying to do is backport software that is at the bleeding edge of where we are to older platforms, to Raspberry Pi old stable, to Raspberry Pi stable, Ubuntu, Debian. It's become about 7 operating systems across 4 different architectures. And then I ran into build systems are really hard, because doing that many things takes a lot of time. So I got into refining my build system, and it became a bunch of scripts, and then that became 25 scripts dressed up in a trench coat, pretending to be a Linux distribution that's now somehow called Hibbian because someone threatened violence if I didn't call it that. And then starting a Linux distribution has brought its own idiotic problems as well. Well, I have to have a website, and I have to have a mailing list, and I have to have a Git repo, obviously, and then that just keeps forking into ever smaller projects and ever smaller hobbies, and that seems to be my hobby, is just forking into more problems. So once people had software from my excellent repo that I spent far too much time on, we hit a new problem. And it is the social challenge of running a network. Keeping the network running depends on all of our participants being happy. And the network will root around interpersonal conflict. What happened at home was I went away for a long weekend, and the guys near me decided that my system was making the wrong noises, and they didn't want to play with me anymore. So they changed frequency, and no one thought to send me a text saying, your system's broken, can you just turn it off? So I got home, and everything was quiet in the house. And I have a speaker on all the time, and I can just hear the noises, because it's just 1200 and 2200 hertz audio. So I just hear little burps of packet going back and forwards, but the house was silent, and that's always worrying. So I went and looked at all the radios, and everything was wired up okay, so I unwired everything, and my radio room is a mess of wires, because there's 7 radios and 5 antennas and all sorts of stuff. And everything was wired up fine, so I wired it back together, turned it all on, and bumped a knob and changed channel and heard everyone else all of a sudden. And that's when I got upset. But rerouting the network does solve other problems. And we recently identified that we have a lot of interference on our shortwave channels, so our long-haul channel. The war in Ukraine has brought a lot of Russian interference on the amateur radio bands. And we found a quiet spot, and we have moved into that quiet spot, and we've applied some channels for different speeds and different networking technologies. And now our network is more interconnected than it was before. We have these reliable links up and down the country that work every day, and we have these links to different countries that work every day, and we can send messages to each other much more reliably now. So when the network roots and we manage the social challenge okay, everything works. And then to send mail, well, this is the mail forwarding screen in our preferred node package, our preferred BBS. As you can see, it's really simple. It's very obvious what's happening here. I am doing something. This is the caliber of software that we have to deal with. And really what I'm doing is sending bulletins to 71 to 78, which is the Scottish packet addressing scheme, to this guy in Glasgow, Michael, GM5AUG. And anyone that sends mail through me goes over my shortwave link to Glasgow. I have one to the Isle of Man. I have one to Reading. They go all around the country. And these are two-way agreements that we've made. We've agreed between us that I will send mail there and they'll send mail back. But these rules aren't set in stone. So there's a guy who is 2 hops down from me who doesn't like sending mail through me. He likes to go through his pal in Edinburgh. So the two of us are in competition to try and attract users from the local area. And it's always entertaining when we meet for a pint. But yeah, the network manually routes around problems. Unfortunately, given the age of some of our operators, occasionally someone dies, and we do have to route around that as well, which is a weird set of phone calls to have. So I came up with a Linux solution, and it was insane, but it turns out I can bring the insanity to FreeBSD as well. So if you want to join in the UK network from all around, well, on the modem side, so to create audio, well, you have soft modems like Direwolf and Qt Sound Modem, which is a piece of software that's reasonably available, and the author does produce binaries for FreeBSD. And if you want hardware, well, there's the Nino TNC, which is a driver of what we're doing, and there's also now a plethora of units on LoRa and other technologies. You need a terminal to access it. You can't just use a regular terminal, and the most common is Qt-term TCP, and again, the author provides binaries for FreeBSD, which is nice. And he is also the author behind the main node stack, and the node stack handles all of the network connections, all of the routing, all of the bulletin board, and the live chats as well. And he released some binaries about 3 years ago for FreeBSD. And I spent a long time banging my head off the wall trying to get the code to build, and it didn't build, and it didn't build. And then last night, I cracked it at 5 past midnight. So the code now builds and runs on FreeBSD 14 AArch64 as of last night. The big problem I ran into was these wonderful if-in-defs FreeBSD, and the compiler didn't like them, so I just removed all of the code, and it built. If you need a computer, well, pick your favorite, find a weird computer and stick it on. Antennas, still not software, but you can build your own, and they're great fun. And yeah, for BPQ, Qt-term, and Qt Sound Modem, if anyone wants to help me get that into FreeBSD ports, I would be really happy to get that into the wider BSD ecosystem, and we can have a more interesting and diverse network. And the picture at the top is my FreeBSD system last night in a hotel, just calling in and saying that I'm running the latest version. I did speak to the author previously about why it wasn't building on FreeBSD, but unfortunately someone had reported a CVE against his incomplete telnet implementation. So he was busy fixing that instead of talking to me about BSD. What's next for our network? Well, IP seems good. That's a technology that's going well. Radio amateurs have a lot of IP addresses. We had 44/8 for a long time, and then sold some of it to Amazon. So now we have 44/9 and 44/128/10, which is about 12.5 million IP addresses, and you can just ask for a /24 to do what you want with. The slow-speed links really don't lend themselves towards IP because they're slow, and IP is quite a lot of overhead, but 9600 does. It is implemented in the Linux kernel, and it will come as no surprise that it is an incredibly wonky implementation with lots of weirdness going on that no one understands. There's bugs that are outstanding for 10 years that no one wants to fix, but it is usable, and you can spend 5 to 10 whole minutes of your own time downloading a crap website in the clear, should you choose to. And of course, because it's no encryption, everything happens in the clear. Telnet, HTTP, no one's been brave enough for null cipher SSH yet, but I'm keen. I'm convinced it's allowed. And software is changing as well. All our software is aging and creaking. It is contemporary with when diskette care was something you really had to think about. Don't put them in the toaster. In 1998, radio amateurs produced a new version of the AX25 spec, version 2.2, which solves a lot of our sore points and pain points that are slowing networks down, and it is barely implemented. BPQ, the node stack that we use, implements it perfectly, but the Linux kernel stack doesn't, and the other implementations, it is unclear whether they do or not. And much of the software is now unmaintained. The Linux kernel has a lack of direct maintenance on the components that are in there, and really it doesn't have to be in the kernel at this point. It's not fast networking. The Linux kernel stack has been wobbly since kernel 3, which is quite a long time ago. It saw really big updates in 5.17, which is about 2 years ago, and it saw more updates 2 months ago in 6.9 that have been backported into 6.6, and still nobody trusts it. It's still not good. And the other problem we have with software maintenance is that the software authors are dying, because some of this stuff was written 40 years ago, 30 years ago, and unfortunately we all don't keep going on forever. And then the paradigms that we're networking with are inefficient and out of date by most modern standards. As I suggested earlier, Layer 2 has a full connection machine that handles requests for retransmissions and lots of other things, as opposed to like Quick's approach of UDP at the base layer that we have now. And if we put TCP and IP on top of that, then we have multiple things asking for multiple retransmissions all the time, and everything gets slow and sticky. And when you don't have much bandwidth, you don't want stuff to get slow and sticky. And then, well, why don't we just start again? Like, we have loads of people now that we can communicate to and push software to and enthuse into doing new things. But it's really easy to suggest a perfect solution to a problem when you have no intention of implementing it yourself. Someone tried, Ian in Aberdeen, MM0ROR, tried spinning off OpenBSD into HamBSD and implementing all of the AX25 in that, and ran out of steam after it turned out that no one would fund it, and it was quite a lot of work, and no one would collaborate, and no one really cared. But I really want to see him work on and finish HamBSD. It'd be great fun to have an OpenBSD appliance that I can just sit down, connect a serial device to, and speak to the rest of the world. Other people are doing this as well. It's not just in the UK. We're not just a weird little country that speaks to each other on the radio. There's a group in the US, or there's multiple groups in the US under a banner known as Tarpin, who use the same foundations that we do. They use the same BPQ node, so theoretically, we could squeeze FreeBSD and others in there as well. They have an installer that is a whole series of shell scripts that download each other and refer to other shell scripts that then download more. And it does seem a bit insane, but it is quite a nice web-based UI. It does live conversation. You get a map of the local area. It's quite nice. There's a system called WinLink, which is global email over HF. And it is largely the same as what we're doing. It's the same bulletin board protocol. It's just dressed up and advertised differently. It is widely believed to be illegal in the UK. Don't get caught doing radio crimes. It is very hard to get caught doing radio crimes, but I wouldn't recommend doing them in the first place. In the UK, our licensing situation is subtly different from our neighbours, and we are not allowed to pass messages that have originated from someone who is not a radio amateur. And that's why we believe that email is illegal. This is a discussion that is happening at the moment, and we'll see what comes out of it. There's an application called JS8 Call, which is store and forwards, always on text messaging, and it introduces the great innovation of TDMA, time division multiple access. The time slots on JS8 Call are 15 seconds long, and it whips along at 12 words a minute. But it is quite reliable, and it borrows its modulation from another protocol and technology called FT8. It's slow, but it is a really efficient use of the band space that we have on shortwave. And there's other networks as well that are leveraging packet. APRS is the most common. That's what my screenshot at the start of the map was. It's more like a chat app, direct messaging. It routes over the internet as well as over the air. And it doesn't care about who is where. It's just repeaters that blindly repeat a signal a couple of hops. It could be more like WhatsApp. It could be more like a chat app. Maybe that's what the kids today want instead of a BBS. I don't know. But yeah, these networks are fun to play with. And then there's also Meshtastic, which is really popular at the moment, and it doesn't require a radio license. It's happening on the license-free frequencies. And that is an experiment in passing messages and dynamic meshing with really cheap hardware that you can get off AliExpress. And there's going to be so many more people trying radio networking and data that I've not heard of that are just getting on with what they like to do. And then technology is changing and improving slowly. The Nino TNC that we use and the multi-mode digital voice modem, which is used to emulate DMR and Tetra, are introducing higher speeds in the narrow channels that we work in. So in our VHF medium-sized links, we can now do 9600 bauds, and in our 25 kilohertz wide UHF channels, we're now seeing 19.2 kilobit a second, which is unbelievably fast. And there's a rapid proliferation around the world of astonishingly cheap LoRa devices, partly through Meshtastic and partly through these just being turned out really quickly. And they are really small. This is one that I got for £15 off AliExpress, and it will send and receive data and messages just as well as the big HF radio will, but over a smaller area. And this is another one that's got inbuilt GPS. So when I'm climbing hills with all of my gear, it tells my partner where I am and if I'm dead or not. And they're small, they're cheap. This one enumerates as a Bluetooth modem, and I can just send data back and forward over it. And this one will appear on a wireless network as a serial modem that I can attach to and send data over. So they are much simpler to set up and use, and it's an all-in-one ESP32-based device. And we're seeing these appearing in our network, and it's really interesting. And then equipment's getting cheaper as well. This is a handheld that comes from China. It's a standard walkie-talkie size. And what's exciting about this is that the firmware has been reversed engineered, and there are new software implementations for the radio. And that means we can tinker with the settings that are inside it, and you can make the turnaround from it transmitting to not transmitting really fast, and use it, and with a couple of soldering board level modifications, do 9600 baud over a £15 radio, as opposed to the 250, 300 pound commercial radio that we had to do up until this year or last year. And then there's new modes. I keep telling people that you can do IP over DVB-S over the amateur radio geostationary satellite that is in orbit. The people that run the satellite don't like permanent infrastructure on it, so we can't always have it running, but it's nice to do broadband couple of megabit wide. There is a development ongoing at the moment called New Packet Radio that takes all of the old technology and throws it out and starts again from scratch, and is effectively a layer 2 bridge. And you attach an Ethernet cable at one end, an Ethernet cable at the other end, and it will handle everything in the middle. There is someone in the UK collaborating with a group in Germany on a new generation of hardware for that, and is being funded from the, I guess, sovereign fund that was gained from the sale of IP addresses to Amazon. And hopefully that will bring hundreds of kilobits up to megabits onto the bands that we're already using largely similar equipment. And then we could take the German approach and just put microwave point-to-point everywhere. Because in the continent, they have the Hamnet, and all it is off-the-shelf microwave gear, slightly detuned to be in the amateur bands. But I, for one, would quite like a return to full-blood TNC, modem, all the logic inside one box, and you just plug your radio into it, plug your dumb terminal into it, and everything's gone. And I think that OpenBSD would be a great target for that, which is why I want HamBSD to help. Here are some helpful links. If you want to get started, there is a Get Started guide at my personal Linux distribution. You can always ask me for help. You can email me. And then these ungainly links at the bottom are some software that will work on FreeBSD at the very least. Apart from Xrouter, you'll need Linux emulation in the middle. I'll put the slides on the program system so that you can download the PDF and click the link, as it's much easier than typing in John Wiseman's documents address. And hopefully, given time, you will join me in combining all of your hobbies and climbing to the top of a mountain in the Scottish Hills with a laptop and speaking to strangers via packet email on a different continent. And then it rains and the laptop gets ruined, and you can't bring it this weekend to play with packet radio in a field in Ireland. Thank you very much. Yeah. I can talk about radios all day. So there's been look at using it, but everyone's a bit scared of just implementing new things. So at the moment we're stuck in the old ways and we're busy reinventing the wheel instead of looking at standards and trying to implement them properly.
What are the legalities for licensed ham operators to reuse unlicensed band devices like Bluetooth long range 5 or
It's
Wi-Fi?
generally okay as long as you stay within the bands. At that point, it is operating under your license as opposed to the license or type rating that is given by the jurisdiction that had it originally.
Does that mean at that point you're allowed to add an amplifier to the output stage and input stage?
Yeah, as long as you're not interfering with other people then. So we have, on the geostationary satellite, it's 2.4 gigahertz uplink, and people are running 10, 15 watt amplifiers off the back of essentially commercial Wi-Fi equipment together. Excellent.
Thank you very much.
Thank you.